Hello, Merry Christmas, Happy New Year. Let's talk about coil sizing and latent load. So this is something that comes up. You've done your load calculation, you've got a system here, and you've got your totals for your load. This is the raw computation. There's 76,000 BTUs of total load. There's people latent, there's ventilation there. And then once you've got your load, you go and you configure your system. So for this package unit, I have a cooling coil and I've got outside air coming in, and I'm going to set this coil to 55 degrees. That's going to be my discharge air temperature. Then when you go back to your loads, you look at the coil sizing. And this is where you see your coil load, 61,000. And your first question may be, why is it different from just my load calculation for this system? And here, 55 degrees, this is a big reason. So with your coil sizing, you've got all the psychrometrics involved, you've got outside air coming in, return air mixing, you've got a latent component, but the capacity of your coil to handle latent load is largely determined by this leaving air temperature that you set. And so this right here, your SHR, your sensible heat ratio, is a big indicator on if you've configured this coil to actually be able to handle the loads that you're calculating for that system. So let me show you real quick how to adjust this, how to fine tune this coil sizing and see the impact really quickly. Right away, when you see 1.0 and you see that your sensible coil load matches your total coil load, that's an indicator that your discharge temperature is not low enough to actually extract moisture from the air. Therefore, you're not able to handle any latent component to your load. So to get this total load up and get closer to what your raw calculated total is here, we need to adjust this coil configuration. And this is really easy to see when you plot the psychrometrics for this coil on a psych chart. And I've gone ahead and done that for this example, where we've got the outside air here, we've got the return air here. This is the mixed air state. And you can see with the coil that I've configured at 55 degrees, that is a sensible only process. In fact, it even has to go up, which is a no-go. We're not adding moisture in this process. And so this is an indicator that my dew point for this mixed air state is lower than 55 degrees. And so I'm not going to be able to extract my latent component from my load unless this discharge temperature is lower than my dew point. So if you use the HVAKR psych chart, which is awesome by the way, you can go to this mixed air state and look at some of those parameters. Here, this is telling me my dew point is 52 degrees. So I need to get below 52 degrees in my discharge in order to actually handle some of that latent load. So let's go ahead and do that, and we can see how this shakes out. So if I pull this off to the side, let's grab this. Now, instead of configuring for 55, which puts me here, I'm going to configure this for 50, and we'll see how that changes. Okay, there we go. Total coil load went up. My SHR is now at 0.89. Sensible is 61. Total is 69. That tells me my latent is about 8,000 BTUs, which now that you have that, okay, this coil is able to extract about 8,000 BTUs of latent load. You can look at your latent components in your load calculation and confirm that that is good. So we're definitely handling all the ventilation latent with this coil. There's a little bit of a surplus on the people latent, which is an interior condition. That's basically going to adjust the return air, which is also going to adjust the mixed air. It's more or less, when we're close, it kind of self-corrects, because if your mixed air condition gets a little bit more moisture, then your dew point is going to go up a little bit. Your coil will be able to extract more latent. So this right here is one thing to pay attention to when you are configuring your system and looking at how your coil data matches with your raw kind of agnostic load calculation here. So that's just a quick primer on looking at your discharge air temperatures, looking at how that affects the psychrometrics, and ultimately how that affects your total and sensible and latent loads for your coil.